Okay, so here what we're going to do is we're going to simplify square roots. So let's look at this problem here. Here we have the square root of 25, and what we're going to do is we're going to simplify it. Now, if you look over here to the left, it says perfect squares, and we have some numbers written in there. So as a reminder, when you're simplifying square roots, you need to be very familiar with perfect squares. And what perfect squares are basically numbers that we obtained by doing such. For instance, to get the number 4, I multiplied 2 times 2. To get the number 9, I multiplied 3 times 3. To get 16 was 4 times 4. 25 was 5 times 5. 36 was 6 times 6. And 49 was 7 times 7. And these dots means that I can continue forever pretty much to get a list of perfect squares. So if I wanted to, the next one would have been 8 times 8, which would have been 64, and so on and so forth. So that's how you get perfect squares. And we need to know the perfect squares because what you're going to do is you're going to see which one of these numbers divides into this number we're taking the square root of. So if I look at this one, it says square root of 25. Well, I noticed that 25 is in the list of perfect squares. What that lets me know is that the answer to this is going to be 5. Why is it 5? Well, when you read something such as the square root of 25, one way you can think of it is by saying what number times itself is 25. That's the way you could interpret a square root. What number, when you multiply it with itself, is 25? Well, to get 25, you just multiply 5 with itself, or in other words, 5 times 5. So going back to this list, as we said before, we did 5 times 5 to get 25. So this is the number we're using to multiply with itself, and that's why that's the square root of 25. Alright, so if any perfect squares that you're taking the square root of, your answer is going to be the number we multiply with itself. Alright, let's look at this example here. Here it says the square root of 32, so we're going to simplify this number. So I noticed that 32 is not a perfect square, it's not in this list. So the next question I ask myself is, do any of these numbers divide into 32? And by looking at this list, I already know that 16 goes into 32. So I'm going to rewrite this in my next step as 16 times 2. Now notice these two are the same thing. 32 is the same as 16 times 2. So even though it looks different, I didn't change the problem because they still represent the same exact problem or the same exact number. This is 32 and that's also 32. So next, now that I have two numbers multiplied together, I can split it up. So I can put them into their own square roots. So here I have 16 and here I have 2, so they each have their own square root. So that's one of the properties of square roots that you can use. And the reason why we want to figure out any perfect squares goes into this is because you can see here now that the square root of 16, or in other words, what number times itself is 16? Well, the number that I used to get this was 4 times 4. So the square root of 16 is just going to be 4. And then I'm going to bring down my square root of 2. And I just ask myself again, do any of these perfect squares go into the number 2? And I know that none of these numbers divides into 2. Or in other words, I can't rewrite 2 as the product of one of these and another number. So I know that this here is my final answer. It's simplified. And then looking at this problem, it looks a little bit different. Here we have 4 in front of the square root. If you see a number in front of a square root, this is actually multiplication. So the 4 is being multiplied with this square root. So you treat it the same way. So I'm going to bring down the 4, put times, and then now I'm going to ask myself, do any of these numbers go into 48? So I know 4 actually goes into 48, and it goes into that 12 times, because 4 times 12 is 48. Now, since I have the product inside my square root, I can rewrite it as the square root of 4 times the square root of 12. And now I'm going to simplify more. So 4 times the square root of 4, meaning what number times itself was 4. Well, I know that the number we used to get that was 2 times 2. So 2 is the square root of 4. And then I bring down the square root of 12. And now I'm going to simplify. 4 times 2, I get 8. So times the square root of 12. And at this point, I ask myself again, do any of these perfect squares go into 12? Well, I know actually 4 goes into 12, so I'm going to use that perfect square again. And I would get 8 times the square root of 4 times 3. 4 times 3 is 12, so I know that this is good so far. And now, since I have a product here, I can split it up as 4 and then 3 here, so they're in their own square roots. And then now I'm going to simplify once more, so I get 8 times the square root of 4, as mentioned before, was 2 times the square root of 3. And finally, simplify one more time. 8 times 2 is 16 times the square root of 3. And now I can see here, do any perfect square, or do any of these perfect squares divide into 3? And I can see that none of these perfect squares goes into 3, so this is simplified. Now, if you haven't noticed, I had to repeat the process of simplifying. Once I got to this point, when I asked myself, do any perfect squares go into 12? Well, there was another perfect square, which was 4 in this case, that went into 12. If that ever happens to you, where you have to repeat the simplifying process, that means you did not pick the biggest perfect square that goes into 48. So, what is the biggest perfect square that goes into 48? Well, one thing that I know from experience is that I know 4 went into 48 once, or not only once, but twice, because that's the number I used to simplify in more than one case. So now, since that's true, I know that if I multiply these two, I know that 16 actually does go into 48. So I can rewrite this as 4 times, and then I put 16 times 3. So 16 times 3 is 48. And since I have a product, I'm going to split that up. So I get 16 square root of 3 here. And now I get 4 times. So square root of 16, in other words, is what number times itself is 16. Well, to get this number, I know that was 4 times 4. So the square root of 16 will be 4. And then the square root of 3, I'll bring that down. And when I simplify now, 4 times 4 is 16 times the square root of 3. And as we got before, you can see we got the same exact answer. But you can see here that it actually took me less steps. And the reason why I didn't have to use that many steps is because I found the biggest perfect square that goes into 48. But as you've seen before, if you miss the biggest number, it's okay, because you'll be able to get to the same answer no matter what. But the only thing I can say from experience is that when you end up using more steps, like I did in the first time I tried it, you're more likely to make mistakes when there's more steps involved. So it does help if you take the time to figure out the biggest perfect square that can go into the number that you're trying to simplify, or the square root that you're trying to simplify. But this is basically the idea behind simplifying square roots.